Good morning. Here is lesson 3, day 2, just a little brief review at the beginning. So you might want to just pause the video and check and do these yourself and then check. Okay, so A, this was a normal distribution. And just because it's showing, letter D would also be considered normal. If we look down the page, letter B would be considered a normal distribution. Letter C would be considered skew, and it would be skewed to the right. And letter E would have been neither. It's not normal, nor is it skew. So hopefully that just brushed up from the weekend. Okay, so now we have a class example and found this little bit of information on these little dinosaurs called compies. And so we have a table of values that go with the heights of these compies, and that actually is on the next page. So here we have this table, and they want us to find the relative frequencies or the percents. Well, before you do that, the first thing I would do with this is I would go into my calculator, I would do second memory 4, I would clear my lists. List 1, I would be putting in the heights, and then list 2, I would be putting in the frequencies. Now, when you have this in, which I did before, you would now make sure that you go stat, calculate, variable statistics. Now, if you have a new calculator, when you do this, you end up at a table like we had said before, that says list, and it says L1. And then below it, it says frequency list, where you will hit second and the 2, and then you would hit calculate. This is an older version. Some of you might have this older version at home, like I have here on my calculator. I have to hit enter, and then I have to physically type in L1, the comma, and then L2. So the new version, you just have to cursor to frequency list, type L2, and then go to calculate. I have to type L1, L2, and then enter. Now, what I get is really important. I get that my mean is 33.5. So my mean is 33.5. And I get then that my standard deviation is 2.56. So here on the calculator, here is my mean, and here is my standard deviation. And hopefully you have the same exact work that I have. Now, relative frequencies are percents. So we do a percent by saying, well, I have to know how many compies I have. So now look at, here's my N. This N is 660. So here I have 660. And then to find the percent, now, here, let's see, that's 11. This would now be 1 divided by 660. And then you do that on the calculator, and that equals 0.00, rounding to the thousandth, 2. And you get to the next one. This percent is going to be 5 divided by 660. And then that would be 0.008. So this is what I want you to do. I actually want you to pause the video and I want you to do these yourself and then come back and check and see if your answers match mine, which they should. So one of the things you're going to notice is that just by the numbers, you can see that this is a normal curve because the numbers have symmetry. And that's going to make a nice, smooth curve, which is what we're going to look at. So when you're done with this, we're going to actually make a graph. And just to check, if you were to add these up, you would be at 1.00. This would add up to 100%. So you know that your percents are going to work. So if you come down the page, it now gives you this graph. And they're asking you now to analyze the graph. So if you notice, the mean that you got from above, which actually I'll slide on down so we can see it. So this mean and this standard deviation, if we look up here, let's make this bar a little bit thinner. This mean of 33.5 is roughly around here. So here would be my mean. And if I added 33.5 plus 2.56 as standard deviation, I would find that my mean plus one standard deviation, or a z-score of 1, would be over here at 36.06. That would be about here, maybe over just a touch. And if I subtracted a standard deviation, so I have a z-score of -1, I would be at 30.94, which would be somewhere around here. And if I continued with my z-scores, if I subtract another z-score, I'm at 28.38, which would be around here maybe. And if I added a z-score to the 36.06, I'd have 38.62, and that would bring me maybe around here. So I can actually add on and then type in my z-score. So this one was 28.38, and this one here was 30.94. Here's my mean, which was 33.5, and then my mean plus the standard deviation was 36.06, and then I have 38.62. So here would be the way this would be labeled if this had an actual normal curve, which, if you look, this is making and I'll try to see if I can draw it. This is approximately normal. Hopefully you can draw better with your pen than I can draw with this mouse, but we're approximately normal here, and that means a lot because now they're asking me these questions. What does the relative frequency of 0.136 mean? Well, this would mean that 13.6% of the copies are 32 centimeters tall. And what does the width of each bar mean? Well, if you look at each bar, you can see that the width of each bar is 1 centimeter. And then what does the height of the bar represent? And that would be the percent of copies at that height. So just kind of analyzing the graph, we'll go through this fairly quickly. Wait, what happened to the bottom of my paper? There we go. What is the area of the bar that represents the relative frequency of copies at 132 centimeters? Again, that would be 0.136 or 13.6%. And the mean of the distribution of the copy height is 33.5. The standard deviation is 2.56, which we found. Interpret the meanest standard deviation in context. Now, this is something that is asked quite often on the Regents level, is to put it in context, meaning, do you understand what these numbers mean? And if we were to do that, then we would say, if we were in class, I would ask you to tell me this, and I know somebody would have said the mean is the average or the typical height of a copy. And most heights are between 30.94 and 36.06 centimeters. And here, the standard deviation, we would hopefully be able to explain. And I really do think that if we were together in class, somebody would be telling me this. The standard deviation is the typical distance the copy's height is from the mean. And if we move on, it's the same graph. Actually, what I'm going to do is cheat a little bit because, and you don't have to redo this, you could just flip back and forth, but I was trying to make things a little bit easier with the smartboard and doing this lesson. So I'm just going to do this. I am going to copy. And I'm just going to paste. Whoops. It won't copy and paste on the smartboard if you're on a page. So let me get to the bottom, paste. All right, and now I have to move this. Let's try it again. Group first, maybe. And now move it. So you could fast forward through this nonsense when the computer does not work well with me. There we go. Okay, here we go. So here they're saying mark the diagram, which we already did, but it's saying approximately what percent of the values in this data are within one standard deviation of the mean? So if we actually were on the normal curve, so if you could pull out your normal curve from Friday, and we look at the percents that are one standard deviation from the mean, those percents come out to exactly 68.2%. But if we look here on our graph, we have from the numbers 30.94 to 36.06, and we actually look at this table, we're going from here. We're saying, okay, 30.94, I can't use the 30. I actually have to start here at the 31. And the 36.06 means I have to stop at the 36. So if I add up all of these numbers in between these two parts, I actually get 75.8. I get 0.758 when I add up all these relative frequencies. So if that adds up to 0.758, the answer here on this page would then be 75.8%. So sorry that we have to flip back and forth. And now if they say approximately two standard deviations, well, two standard deviations were 28.38 and 38.62. So now I go back here, and now I am looking at the 28.32 means I can't start at this because I was above, I was 28.3, and this is just 28, so I actually have to start here at the 29, and then if I'm going all the way up to 38.62, again, I have to stop here at 38 because that's 38.62, and this one doesn't, stops. And so when I go in between these guys and I add up all these numbers from here on down, I end up with 0.946. And so if we come to the other page, this here would give me 94.6%. So we already drew the curve, and if we're looking at the area under the curve that represents one standard deviation, we would look here, and let's use one standard deviation would be this part here. And you can see most of the data is clustered within one standard deviation. And when we looked at our numbers, 75.8, roughly 76%, that's a lot of numbers clustered within one standard deviation of the mean. And so based on your analysis, how would you answer how tall is a compy? And so here we would say a compy was roughly 30.94 to 36.06 centimeters in height, or you could have said 31 to 36 centimeters in height, because that's roughly what we're talking about. So now we have example 2, which is a gas mileage problem. And this gas mileage problem, I would like you to go back to your calculators, and I would like you to do the second memory 4. I want you to clear your list, and then hit stat. So if we do that, second, memory, 4, clear your list. When you go back in now, you have only one list. So make sure you're on the list 1 and just get list 1 in. Now, when you go to stat variable statistics, you have to make sure that you take away L2 in the frequency if you have a newer version of the calculator. An old version, it's not a worry, but a new version, it's going to have frequency, and you've got to get rid of the frequency or you would have the wrong answer. So you pause the video, do that, and then come back and check your work. So you should have gotten the average is 26.04, and you should have gotten the standard deviation is 1.51. Okay, so our average 26.04 and our standard deviation is 1.51. Now, the next thing they want you to do is they want you to take this data list and they want you to organize it. So basically, you have to find the frequency and the percent. So again, pause the video and do that, and I will do it as well. So this was 1. Next. So hopefully your frequencies and your relative frequencies match mine. And now again, pause the video and see if you can make yourself a nice histogram. I'm going to do that now with my data. And notice that you're going up to relative frequencies. And each number is in between. So if this is going up to 4%, whoops, I got to get rid of the arrow. You're stopping before the 5. You're definitely stopping before the 5. Try to make your bars as neat as you can so that you can read it. And then the next one goes up to 12, which is here. And then 20. And then 28. And then 20 again. So hopefully your histogram looks like mine. Describe the shape is the first thing they're asking you for. Like, what do you think about this shape? And for me, I would say the shape is approximately normal. It's an approximately normal shape. So actually, I should have put a yes here. So let me just, yes, approximately normal. Mark the histogram with the mean and the standard deviation. So again, when you did this, you found that you had a mean of 26.04. So let me just get a different color bar here. Let me make my bar, nope. Let me make my bar orange, I like. All right, so 26.04, so roughly here is my mean. And one standard deviation, 26.04 plus 1.51 gives me 27.55. So that would be roughly around here. And 26.04 minus 1.51 gives me 24.53. Yes, that would be roughly about here. So that looks about right. This looks about one standard deviation each way, because now if I were to draw my curve, does this look approximately normal? And it does. So this was my mean plus the standard deviation right here, which brought me to my 27.55. It was my mean at 3.4. I don't know why my pen stopped working, but this will work better over here. Okay, that's not good. Let me see if I can get my, all right, looks like my computer, maybe I lost Wi-Fi, doesn't want to work. Let's see if it's back. Okay, looks like it's back. And I'll just type this one over here as x minus a standard deviation. And that was 24.53. Okay. There we go. All right. So from there, that would be, I guess, the answer. That would be my 24.53 to 27.55. So that was, you know, hopefully you fast forwarded through where my computer was moving slow, or you paused and you did your work, because this really shouldn't have taken too long. But now we have to really talk about those z-scores that were at the bottom of the normal curve last week. These z-scores actually are a calculation of the value that we're talking about minus the mean. Now, if it's positive, this would be above, this would be a positive z-score. If this is negative, this is a below the mean. This is, you know, to the left of the mean on the normal curve, divided by the standard deviation. So what we're going to do are some problems that are fairly similar to the problems that we did last week, but now we're going to use the z-score with the normal CDF on the calculator and just see how it works both ways. And sometimes you're asked for a z-score, sometimes you're not. So we're gonna just do the best we can with that. It says the price of a printer in a store is $240 and a standard deviation of 50. And the printer you want is 340. So what's the z-score of your printer? So the z-score of your printer is going to be $340 minus the 240. And you're going to divide that by the 50. And that is going to equal 100 over 50, which will give you a z-score of 2. And that's a positive 2. So this means that the printer you want is above the mean. So if I just make these into nice. So you chose a more, clearly a more expensive printer, and you are now above the mean. And so how many standard deviations above the mean? 2. You are 2 above the mean. Now, so this is your z-score. So then it says, that's it. They just want you to find the z-score. Aisha's height is 63 inches, and the mean height for boys at his school is 68.1 inches, and the standard deviation 2.8. What's the z-score for his height? So the z-score, I'm going to try this. The z-score equals, and now a fraction, which would give me in the top of the fraction, hopefully this is in the right spot. Actually, let me do this. Okay. Now, all right, now I know I'm in the right spot. So now this gives me 63, his height, minus 68.1, because that's the mean. We're going to divide this now by the standard deviation, 2.8. And when you type this in on your calculator, that's going to give you a standard deviation of negative 1.82. So he is below the average. So what does this mean? This means this means that this boy, Ashish, is 1.82, almost 2 standard deviations. That means he's shorter than most of the kids that he's going to school with. So that would be the value. So he is 1.82 standard deviations below the mean. He is shorter than most students he goes to school with. All right. So now if we start moving into the z-score and calculating, estimate the probability that Amy's time, oops, sorry, didn't read the problem. Amy's a swimmer, and she has a mean of 39.7 seconds with a standard deviation of 2.3 seconds. So let's underline that. So she has a mean of 39.7. That's the mean right here. Actually, I'll just do this. There we go. And she has a standard deviation of 2.3 seconds. So if we were going to think about this, estimate the probability that Amy's time is between 37 and 44 seconds, we could think about the normal curve and just sketch a fast normal curve. Here's her mean of 39.7. And we're thinking about 44 seconds up here, which is above the mean, and 37, which is below the mean. So if we're looking at this, we're, estimating that we're probably around, I don't know, 70, 80%. It looks like a lot. So since it looks like most of the graphs say maybe 80%, so we're just taking a look, 80%. Now we could also go to the normal curve from Friday, and we could label the mean, and we can actually add 2.3 seconds. So if we did that, we would add a standard deviation, and we would get, I'm just going to change my color, if I went one above, if this is where the z-score of 1 was, this would actually have been 42. And if I went another standard deviation above, I would have been at 44.3. So we were pretty close to 2 standard deviations above the mean. And if I went back a standard deviation, I would have been at 37.4. So I was really close on the normal curve. If we look at the normal curve and we add up all the percents that went from this, the black -1 to the black +2 on the actual normal curve, we would have gotten 81.4%. 81.8%, excuse me, I read that wrong. So that's pretty significant. That tells us that most of her times are falling within this range. But now they say use the z-score, and they want us to find like the actual work with the z-scores and what the actual z-scores are. So let's go to the z-score and let's find the z-score of the lower. All right, so now we're looking at the one to the left, and that's going to equal the 37 minus the 39.7 divided by the standard deviation of 2.3, which gives me negative, and I get 2.7 over 2.3, which is negative 1.174. So my lower z-score is negative 1.174. Now, my upper z-score, let's find the z of the upper and see what z-score that is. All right, forget that little thing is that I clicked on accident isn't there, because if I go back, I'm just going to lose all of it. So 44 minus 39.7, the minus the mean over 2.3. And if you type this in now, you get 4.3 over 2.3, and that equals 1.870. So here are my z-scores now. I have this lower z-score, which is negative 1.174. I have this upper z-score, which is 1.870. And now if I use the calculator with this, I am going to be typing in, and now I'm going to type it first, and then I'm going to do it on the calculator. So if you do this, your calculator is going to say normal CDF, just like it did last week. But now we're going to use the z-score. So we're going to have negative 1.174. It's going to have a comma. So the older calculators, you literally type in the comma. The new calculator, you're on the list and you hit enter after you type this. To the upper 1.870. And again, you would hit enter. I have to hit comma. But now we're using the normal curve. So the mean was always at 0, and each standard deviation is listed as a z-score of 1. So if I use the normal curve z-scores and I hit enter on my calculator, this is going to give me 0.849 or 84.9%. So using the normal curve would have given us around 81, 82%. Using the actual data gives us almost 85%. They're pretty close, but if you can use the calculator and do the exact calculation, you're going to be so much better. So again, let me use the calculator and just show you. Again, I have this old guy, there's nothing I can do about it. If I do second variable distribution number 2, there's the normal CDF. And now I have to hit negative 1.174. I need the comma. You would hit enter. 1.870, comma, 0 for the mean, and 1 for the standard deviation with the z-scores. You hit enter, and there's the same answer that I had just gotten. So this is pretty standard. What I would like you to do is try to do some more of these. There's 2 more problems, and then you have homework that has 5 problems. It's all about using the calculator. You can use the z-scores, especially if they tell you to use the z-scores. You have to use the z-scores. And if they give you the opportunity to, just type things in, if they don't tell you you have to use a z-score, I would not. So if you pause and you find the normal CDFs yourself, do the work, and now check your answer. So letter D, this one would have been, and you had 2.30. They want you to go above, so that's the 999, the 0, and the 1. And this gives me 0.011 or 1.1%. E, you should have had that this means 45 or more is 1.1%. And then F, you should have gotten the z-score. 7 over 3 equals negative 1.61. And then when you now use the calculator and you have your normal hopefully when you're checking your work, you're doing well. And the weights of cars going over a bridge, now this one's not telling you which way to go. So you could either use the z-score or the actual. So I am going to, on my answer key, I'm going to do it both ways. But right now, if I did this one and I used the actual, I would have to go back and put in the mean and the standard deviation. So that's the difference. If you're using the z-score, you have to calculate the z-score, and you have to then calculate the z-score. You have to use 0 and 1. If you're using normal, you can just, using the actual, you could just put in what they have. So your homework, you have 5 problems. I will have the answers posted tomorrow. Good luck.